Welcome to my classroom. In this model 4 humidification in master answer 1 course, in the previous lecture we have seen how to construct psychrometric chart, and I have told you the procedure how to determine the parameters if any two parameters are known. Okay, so in this lecture we will solve few numericals using psychrometric chart and definitions of all these parameters, like what is humidity, what is absolute humidity, what is percentage humidity or percentage saturation, what is humid volume, what is humid heat, and total enthalpy. So all these we can determine either using formulas or psychrometric chart. Let's solve few numericals. Be ready with your calculator and have psychrometric chart xerox copies or photocopies of psychrometric chart printouts, and you mark your all the charts and you have to submit all the charts to me. Okay, so in this psychrometric chart, in the previous lecture we have defined what are the each terms associated with it, and we have seen what does each axis represent in psychrometric chart, and we have seen how to get data, like for example x-axis is dry bulb temperature, y-axis is humidity, and what to do: heating, cooling, humidification, dehumidification, evaporative cooling, sensible cooling, heating and humidifying, cooling and dehumidifying. All that have been explained, and these are some of the formulas which we should know how to determine the parameters. If partial pressure is known, how to determine molar humidity? It is number of moles of water by number of moles of dry air, which can be written as partial pressure by partial pressure of A by partial pressure of B, where A is water vapor and B is dry air. And if molar saturation humidity, how to define, how to calculate it. We have seen how to determine the relative humidity or relative saturation. It is the ratio of partial pressure by vapor pressure into 100. Okay, and we have seen what is percentage humidity. It's N by Na by Nb ratio at the given condition to that of same ratio at saturation. We have seen how to make use of steam table to, if relative humidity is known, what is the corresponding saturation pressure at the given temperature can be taken from the steam table. So steam table where temperature versus saturation pressure is there, we can take the data, which that data can be made use to determine the vapor pressure. For example, relative humidity is known. Relative humidity is equal to vapor pressure by saturation pressure. So we have RH is given, and saturation pressure, if you know the temperature, we will have get from steam table, you will get the saturation pressure, we can determine the vapor pressure. Okay, so and to determine the mass density, if you know absolute humidity can be taken from the chart, and we can get the specific value also from the chart, and we can determine the vapor density. And similarly, how to get the heat added, we need the mass flow rate, which can be obtained by, if you know the initial volume is given in meter cube, if we get specific volume in meter cube per kg from the chart, we can able to get the mass flow rate. So, and H1, H2 are enthalpy value, which can be taken from the psychrometric chart, and we can determine the factor. Another factor is bypass factor, which is defined as the dry bulb temperature minus adiabatic dew point divided by dry bulb temperature minus adiabatic dew point. So these are 2 points, 1 and 2. So we can find out the bypass factor. This formula is used. Okay. Similarly, if to determine the sensible heat factor, if this kind of process is involved, so we can know the H1, H2, and H3 can be obtained by drawing a triangle, where we can get H3 value. Substituting, we will get the sensible heat factor. Similarly, what is the heat extraction or addition capacity is your m dot into H1 minus H2, where m dot is volume by specific volume, which I explained some time back. Okay, that is the capacity of a cooling coil, also can be calculated in the same way. Okay, and the amount of water vapor added or removed can be calculated by the mass flow rate into absolute humidity at condition 1 and condition 2, and the initial and final can be used to determine the amount of water added or removed. Okay, and we have, I told how to convert the heat added or removed. Heat capacity can be converted to tons of registration using the conversion factor. 1 tons of registration is equal to 211 kilojoules per minute. Okay, so there is another factor called contact factor. It is mainly for heating or cooling coil. So this equation can be used to determine the contact factor. Okay, so now we will start solving numericals using psychrometric chart. Okay, now we are going to solve numericals using psychrometric chart. Okay, how to solve numericals? Okay, we have seen the definitions of what is dry bulb temperature, wet bulb temperature, relative humidity, specific volume, humidity ratio, and enthalpy. And if any two data is known, how to determine the other data using formulas and psychrometric charts have been explained. Now let's solve this problem number 1. The humidity of air water vapor system at dry bulb temperature of 55 degrees Celsius is 0.03 kg of water vapor per kg of dry air. Determine molar humidity, relative humidity, saturation humidity, percentage humidity, humid volume or specific volume, humid heat, enthalpy, heat to be added if volume of air is 100 meter cube. Data given is vapor pressure of water at 55 degrees Celsius is 118 mm mercury. We know that atmospheric pressure is 760 mm mercury. We know ratio of partial pressure by P total minus PA. It should be P total minus by P total pressure minus partial pressure. So we get molar humidity. So all these relationship we know. What is Y, what is Ym? It is absolute humidity, it is molar humidity. So this is kg of water vapor per kg of air. So if you multiply by the respective molecular weights, divide by molecular weight of water is here 18 kg per kg mole. So we get kg mole of water there. So if you add 28.84 or 9, 29 also you can use. You get the when you multiply y by these values, you get ym. Okay, so this ym is, and then it can be also related to other parameters. Okay. So how to solve this problem? So here two data are given. So here two data are given. Okay, dry bulb temperature is given as 55 degrees Celsius and absolute humidity is given as 0.03. Okay, we can say Y or H. Okay, 0.03. So if you take any psychrometric chart, which you see whatever psychrometric chart we are going to use, that we should see that its x-axis temperature is of more than 55. Say for example, some of the charts may stop at 50. So in that you cannot plot this 55. Okay, so that way we should go for something which is having minimum 80 or 70, so that we can plot 55 degrees Celsius in the x-axis. Okay, similarly y-axis value also we should see whether it is having 0.03 or not. Sometimes it may stop at 0.02, that we cannot use. Okay, so that way while choosing the chart, appropriate chart is important and looking for the data. Okay, so if for example I have seen this one where we have 55 degrees Celsius. So data given are 55 degrees Celsius dry bulb temperature and 0.03 absolute humidity. So we can see that you can see 0.03 here and 55 degrees Celsius here. So where we have to mark the point, we can mark the point here. Okay, so that will be our point. So that is our point where we will take all the data. Okay, so if you look at this point, the corresponding values we can determine. What is the easiest one to get? Easiest one to get is dew point temperature. How to get dew point temperature? So we will take the parallel line in x-axis up to 100% and the corresponding x-axis value will give us dew point temperature. Okay, so the dew point temperature can be drawn by drawing a line parallel to x-axis up to 100% saturation line. Remember, this is the relative humidity lines. Okay, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So up to 100, this is 100% relative humidity line. So the corresponding x-axis value, so half of it is 32.5, so half of it will be 31 something. So we can say that it is around 32. It's less than 32, or you can say 31 point. Actually, with the scale you have to take exactly. You can divide it into 10 equal divisions and then report the value of dew point temperature. Okay, please report the dew point temperature by dividing this into, we can divide at least this into 5 equal divisions. 5 means what? There should be 4 lines coming in between. Okay, so once you get 4 lines, so it may be coming less 2 3 4, so 2 lines are coming. So accordingly you can report the value 31.5 to 32. You will get the value of dew point temperature. So that is one data we can get. What else you can get? The next parameter you can get is, you can draw a line, blue color line. What is blue color line referring to? Blue color line referring to wet bulb temperature or saturation temperature. So these blue lines, so you can see the values -5, 15, 20, 25, 30, 35 is here. Okay, so and 30 to 35 is this much big length. So this line is parallel. We have to draw a line parallel to these blue curves, not black curve. Okay, black curve is different, that is enthalpy value. So this blue curve is wet bulb temperature line. So we have 30 to 35 is this much big size. So half of it will be 32.5, half of it will be 31.25. So you can say that 1.25 is the distance of this. So you can say 35 plus 1, 36. 36.5. So between 36 to 36.5, please report in your psychrometric chart. You have to make equal subdivisions and then find out the value. So you have a value parallel to this. So this value is our wet bulb temperature. So we get a wet bulb temperature of around 36 to 36.5. Okay. Next, what you can get? Enthalpy data. Similar to this blue line, we have drawn a line parallel to this blue line and we got this line. So next, this, if you draw a line parallel to this black line, okay, in this case it may be parallel, but in other cases it may not be parallel. Okay, so first we have to draw a line parallel to this black line. So here also 100, 120. That means half of it will be 110. Right, 3/4 will be 115. Okay, that means 15 will be there. Okay, so here beyond 120 it is 140. So if you have a line, half of it, it is going to be 130. So it is slightly more than that. You can say 135. Right, so we have enthalpy value of 135 joules per gram dry air or kilojoules per kilogram dry air. So we get the enthalpy also, value also from the graph. Okay, can we write down whatever we have got? Okay, let me write down here. So we have dry bulb temperature equal to 55 temp and absolute humidity HRY is equal to 0.03. So for this value, whatever we get, we got dew point. Dew point is something 31.5. I said it is 30, 32.5 will become here, right? 31 will be here. So it's slightly greater than 31. Okay, 31.25, let me say. Then we have seen what is wet bulb temperature. Wet bulb temperature is more than 35 and we can say 36. Okay, and then now we have seen enthalpy. Enthalpy is joules per grams of dry air. You can say kilojoules per kilogram. So what is the value? It is around 135. Okay, I'm just giving a random value. You have to write exactly where it is bisecting. Okay, divide into subsections and then get the values. Okay, what else we can get? we can get a line. If this is specific volume is given, right? So specific volume is given. So this green line, we are having a green line here, right? So we are having a green line here. So remember, this is the line. This is one green line. This is one green line. So this is one length of green line, right? So we can draw a line parallel to this across this point. Okay. So if you draw a line parallel to this, so how to get the value, corresponding value? So you can see that this gap is so this is 0.9, this is 0.95, and this is 1. That means each between this one length is equal to 0.05. Okay, so if this much is 0.05, half of it will be 0.025. Okay, 0.025. Half of it will be total is 0.05. This one is 0.025. So accordingly, you can write the value. What would be the value at this line? It is 0.95. It is 0.1. So that means another 0.025. If you add, it may be it's 0.95 already. So 0.975 you can say. Okay, so the specific volume is, so how we write? Here it is 0.90. Here it is 0.95, it is 1. So already 0.95 plus half of this 0.05, because it is like half of it, not even though not exact half, close to it. Okay, so 0.024 or 0.025, we get 0.975 as the specific volume. So specific volume is equal to, what is the unit mentioned? It is meter cube per kg dryer. This much meter cube per kg dryer is specific volume, which is 0.975. Okay, so these are the data that we have obtained. So actually relative humidity also we can be obtained, right? So exactly this blue line is coming here. So this will give us the relative humidity. So relative humidity percentage RH is equal to 30. So we have, how many data we have collected? 1, 2, 3, 4, 5. Okay, so for the 2 data is given, we have taken 5 data from the graph sheet. If remaining like percentage humidity, all that can be determined using the formulas. Okay. So what we have done here, this length is 0.05. So we have taken the line and drawn a line there, and we have seen what would be the value. Okay. So what are the parameters? Also we can solve the same problem using the formulas. So what are the data given here? Here it is given like dry bulb temperature is given like 55 degrees Celsius, and absolute humidity is given like 0.03 kg of water vapor per kg of dryer, right? Now this can be called as Y or H, okay, depending upon this thing. So this is if it is kg, you have this. Otherwise, you can write like molar humidity, right? So how this Y can be converted into Y dash, or Y dash is molar humidity, absolute molar humidity. Okay, so that is we have to. So this, as I told earlier, we have to multiply and divide by their molecular weights. So if you, so what we can do is equal to 0.03 kg of water by kg of air. So if you want to divide by 18 kg of water per kg mole of water. Okay, similarly for air, 28.89 kg of air by kg mole of air. So if you cancel it, what we get? 0.03 into molecular weight of air divided by molecular weight of water gives us Y dash.
Okay, so in general, if Y is absolute humidity in mass, and if you want molar humidity, so what you have to do is Y dash equal to Y into molecular weight of air by molecular weight of water. Okay, remember the molecular weights of air 28.884. Sometimes you can take 29, no issues. Molecular weight of water is 18. Okay, so we have, so you can convert the given data 0.03 into 28.8 divided by 18 gives us the value in kg moles of water vapor by kg moles of dry air. Okay, so what is the value? Please calculate. 28.8 divided by 18 is zero point 0.6, right, into 0.03. Yeah, it's 1.6 into 0.03, 0.048. Okay, so what we get is 0.048 is the molar humidity. Okay, now with this molar humidity is also defined as the ratio of partial pressure, right? So you can say that partial pressure of A by P minus PA is equal to this Y. Okay, so what is Y value? Y value is this is Y dash. Okay, so this is 0.048. Okay, so here I am using Y dash as molar humidity. Okay, so different book will use different notations. So this molar humidity is equal to ratio of partial pressure of A by partial pressure of B. You can say that. So what we have is partial pressure is can be determined now, because Y dash value we have now 0.048 is equal to partial pressure we don't know. So total pressure is atmospheric pressure means 1, or if you data is given in terms of mm mercury, so you can say 760 minus PA. Okay, so from this we get what is PA value. Simplify to get what is PA value, so we will get around 35 mm mercury. Okay, please use your calculator. So simplify this to get what is PA. So that is, first we have to 0.048 into 760 minus PA is equal to PA. So we have minus 0.048 PA here. 760 into 0.048. 760 into 0.048 is equal to 3.648. 3.648 is equal to PA plus 0.048 PA, that is 1.048 PA. Okay. Therefore, PA is equal to 3.648 divided by 1.048 is equal to 3.481. 3 point, not 3 point, no, it's 760. 760 into 0.048 is equal to 36.48. Okay, here it is. 36.48 divided by 1.048 is equal to 34.8 mm mercury. Okay, so that's the partial pressure. So if you know the partial pressure, we can find out the relative humidity. Okay, so how to get relative humidity? Relative humidity is defined as the ratio of partial pressure by vapor pressure. So what is partial pressure? We have determined 34.81. What is the vapor pressure? Vapor pressure is given at 118. Both are in same unit, that you have to take care. Okay. Okay. So the relative humidity is into 100. Okay. So what is the value? Relative humidity is equal to 34.81 divided by 118 is equal to 29.49. 29.49 is the relative humidity. So you can compare the value with the graph method. From the chart also we got almost as 29.5 or around 30 relative humidity. So here also we have similar value. Okay. Obviously there will be small difference between the values determined by formula and chart. Okay. So this we have done. Next to find out is you can find out what is the saturation humidity. So relative humidity we have determined. What is saturation humidity? So the saturation humidity is equal to Hs. Okay, so that is we have the vapor pressure. So what is that? Vapor pressure by that is Pa naught by P minus Pa naught. That will be our saturation humidity. So 118 by 760 minus 118 gives us the saturation humidity. So what is the value? 118 divided by 760 minus 118. So you get 118 divided by, yeah, 118 divided by 760 minus 118 equal to 0.183. 0.183 kgmoles of water vapor by kgmoles of dry air is the saturation humidity. Okay, Hs. And we can determine what is percentage humidity. What is percentage humidity? It is H by Hs. Both should be in same units. Okay, so H in terms of H is here we had Y, right? Y dash. So what is the value? We have 0.048 as the molar humidity. Okay, let me write Hm by Hm saturation. Okay, so both should be there. You can even do it in terms of absolute humidity also, but here we do it in terms of kg moles. You can do it in terms of kg also. Okay, so it is either H by Hs or Hm by Hms. Okay, so what we have is 0.048 divided by 0.183 into 100. It's also expressed in percentage. So we have this. So if we substitute this, what value you get is 0.261. Okay. Next, we can determine humid volume. By formula, what is the formula for humid volume? So it is again specific volume which we already determined using graph. This is formula method we are doing again. Okay. Okay. So humid volume is equal to, there is a formula. Make use of that, 8.314 divided by 101.325 into whatever is the dry bulb temperature plus 273 into 0.03. What is that 0.03? It is absolute humidity divided by 18 plus 1 by molecular weight of air 28.8984. Okay. So this will give us, if you substitute dry bulb temperature is 55 degrees Celsius, right? So if you substitute that, you will get humid volume value 0.978 meter cube per kg of dry air. Okay, so that is the formula to determine humid volume. Okay, and similarly you can determine what is humid heat. How to determine humid heat? Humid heat is equal to, so there is a formula, Cs is equal to 1.005 plus 1.88 into H. Okay, so 0.03, that is absolute humidity you have to use. So absolute humidity in terms of kg. Okay, so that is 1.005 plus 1.88 into 0.03 gives us humid heat. So that's your Cs value. You will get 1.0615 kilojoules per kg. Okay, so this way, using both graphical method, using psychrometric chart, we can get many values, and remaining values can be determined using the formula. In this example, we have calculated using chart, psychrometric chart, as well as using the formula. Okay, any one is sufficient, but extra parameters like humid volume, particularly humid heat, needs to be calculated using the formula. Okay, now look at this problem, second problem. Air water vapor mixture at a location in a cooling tower has a characteristics as follows. It has a dry bulb temperature of 50 degrees Celsius and a humidity of 0.05 kilomoles water vapor per kilomoles dryer. That is, absolute humidity is given in terms of mass. Sorry, in terms of moles. Okay, so absolute humidity is given in terms of moles, and total pressure is given as 1 atmosphere. Determine absolute humidity, percentage humidity, humid volume, humid heat, and total enthalpy using chart, that is psychrometric chart. Okay, first we will do using this. Okay, so take a chart where we get the value of 50. Okay, so in this chart, if I say there is 50 is there, and what is the other data given? 0.05 kilomoles of water vapor per kilomoles of dry air. What is the unit given here? It is in kg, grams per kg it is given. Okay, so what we can do, I can do one thing here. It is 0.05 kilomoles of water vapor, right? Water per kilomoles of air. So how to convert it into kg? So I can convert by 18 kg per kg mole of water, right? So this kilomole will get cancelled. Similarly, 28.84 kg of air per kg mole of air. Okay, so this kg mole also will get cancelled. So thereby I get the data in terms of kg of water vapor by kg of dry air. Okay, so what is the value? 0.05 into 18 divided by 28.84, 0.014. So whatever is the closest value we can take. Okay. So in this 0.014 is the one which we have to use. Okay, so this is 0.014 kg of water vapor. That means it is 14 grams of water vapor by kg of dry air. Okay, so are you able to see that one? 14 grams of water vapor. Yes, so it is given grams of water. Okay, so here it is 15 is here, so somewhere here we have to take the value. Okay, so 50 degrees here, so this is our dry bulb temperature. 14 grams of water vapor per kg of dry air is the data here. So somewhere 10, if I divide here 11, 12, 13, 14, 15. Okay, somewhere here is the our point. Okay, so we have to mark our point at a dry bulb temperature of 50 degrees Celsius and 14 grams of water per 15 kg dryer, 14 grams of water per kg of dryer. So here we can mark the point. So then we can go to get all the parameters. Okay, so first we can find the dew point temperature. How to get dew point temperature? Draw a line parallel to x-axis until it touches the 100% saturation line. Here what is 100% saturation line? This is not the line, it is C-shaped curves, right? So 6, 40, 30, 60, 80. So red one is 100 percentage. So draw a line parallel to that. So first what we get is, if you draw a line parallel to this, wet bulb temperature line is there. Also enthalpy lines are there. So if we draw a line parallel to wet bulb temperatures, so our this temperature is 25, this temperature is 30. Okay. So what is this value? So half of it, between 25 and 30, half of it will be 27.5, right? So if we divide it into 1, 2, 3, 4, 5, you can divide, if we make it half of it, so half line will be here. So here it is 27.5. So our value will be, this is 2.5. 2.5 here means 1.25, half of it. Yeah, so it is 1.5 we can consider. So we can say 26.5. It is between 26.5 to 27. Okay, so we have get, what are the data we are getting? We get wet bulb temperature is equal to between 26.5 to 26.9 somewhere. Okay, so degree Celsius. Next, we can get enthalpy value. Enthalpy is, if I draw a line parallel to these black lines, so here it is 80, here it is 90, somewhere here you are going to get. Okay, so if you draw a line, extend it up to this enthalpy line, half of it is 85. Okay, so half of it is 85. So you can say further half is 82.5. So we can say it is around 83 kilojoules per kg dry air. Okay, so enthalpy is this. So what else we can get? We can get dew point temperature. Okay, dew point temperature is this one. So if you draw a line up to here and corresponding x-axis value is this. Okay, so half of it is 7.5. Let me say 6, 7, 8, 9. So almost less than 9. Okay, so dew point is around 9 degree Celsius. Okay, so that we have. Then also we can get the specific volume line. Okay, so specific volume line we can get. So this is 0.90. So this is 0.92. Okay, 0.90, 0.92. So this is 0.87. That is every 3. So this is 0.93 line. Okay, 2 digit, no, they given like this. Okay, so the line correspond, if you draw a line parallel to this, we are going to have, each line is having a length of 2.90 and 0.02. So half of it, half of the distance will be 0.01. So this is almost equal to 0.01. Okay, so we can say the value is almost 0.93. Okay, so we'll get a line parallel to 0.93. So that way specific volume is equal to 0.93, whatever is the unit, meter cube per kg dry air. Meter cube per kg dry air. What are the parameters? Whether it is asked or not, I am explaining all the points. Okay, so relative humidity, if you look here, so it is less than, this is 10, this is 20. So half of it is 15. Okay, 16, 17, 18, 19, 20. So it can say 18. Relative humidity relative humidity is 18%. Okay, so these are the parameters which we could able to get it from the psychrometric chart. Remaining parameter we can determine using the formulas. Okay, so how much we got? Relative humidity is this much. Okay, enthalpy also we got around 83 kilojoules per kg dry air. Okay, so you can find what other parameters are asked here. You can find out the total enthalpy we have found using the chart: humid heat, humid volume, percentage humidity, absolute humidity. Okay, so humid heat you can determine using the formula. Okay, so what are the different humid heat formula is? So previous problem also I showed you, it is 1005 plus the formula. Okay, so what is the formula we used here in the previous problem? 1.005 plus 1.88 into H. Okay, same we can use 1.005 plus 1.88 into H. So this should be in kg. Okay, kg per kg. So what is the formula? 1.005 plus 1.88 into absolute humidity is mentioned in this problem, 0.05. Sorry, how much we got? 14 grams per 0.014. 0.014. Okay. Point 0.014 into 1.88 is equal to plus 1.005 equal to 1.03 is the humid heat. Okay, so this way you can make use of the psychrometric chart. Please take down this next problem. So we have an air is entering into a cooling tower with characteristics as follows: dry bulb temperature is 25 degrees Celsius and wet bulb temperature is 22 degrees Celsius and the pressure is 1 atmosphere. Find humidity, percentage humidity, relative humidity, dew point and enthalpy. Okay, so how to solve this problem? So again we can look, so the temperature are very less, 25 degrees Celsius, and wet bulb temperature is 22 degrees Celsius. So we have dry bulb temperature 25 degrees Celsius and wet bulb, this is dry bulb temperature 25 degrees Celsius and wet bulb temperature is mentioned as 22. So here we have 20 is here, 25 is here. So if you divide them into 4 equal parts, I can say 5 equal parts, 4 lines should come: 21, 22, 23, 24, 25. So how much it is mentioned? It is given wet bulb temperature is 22 degrees Celsius. Okay, so we can mark 22 degree line, wet bulb temperature corresponding to wet bulb temperature. Okay, so corresponding to this 25 line is here, already it is there, dotted line, so I didn't draw a line separately. Please show it. So here we have the point corresponding, our point is with this wet bulb temperature, dry bulb temperature. Point P is dry bulb temperature comma wet bulb temperature. Mark point P. So we have marked that one. So whatever parameter that can be determined using this chart, we can do it now. Okay, for regardless of whatever is asked in the question, we are going to get whatever possible to take out. Okay, so first point thing is you can get the corresponding enthalpy value, because easily if we extend the same line up to this enthalpy curve, So we have 60. So half of it is 60, 65. So you can say 66, 67, 68, 69, 70. So we can say around 67. Okay, because half of it will be 67.5, slightly less than that. So we get the enthalpy data is equal to 67. What is the unit? Kilojoules per kg dryer. Okay, so we got the total enthalpy value. Okay. Okay, next we can determine the dew point temperature. For that, what you have to do? Draw a line parallel to x-axis up to 100% saturation line. So we have our saturation line here, 180, 60, 80%, 100% line. This red line is 100% line. So draw a line horizontal and then vertical line to x-axis. We get the corresponding value in the x-axis is, let me say 22. So half of it is 22.5. Slightly less than that. Okay, so dew point temperature is 22.2 degrees Celsius. Now, what else you can get? You can get what is the corresponding absolute humidity, because we have wet bulb temperature and dry bulb temperature given. We don't know what is absolute humidity, so that also can be taken by drawing a line towards this y-axis. So here it is given in terms of grams per kg of dryer, grams of water vapor per kg of dryer. Okay, so what is the value? So here it is 15, half of it is 17.5. So it is exactly even, okay, this is half of that. So 1.5 is 0.75, 2.5 actually, right? So it is 2.5 means 1.25 we can add. So it is around 16.25 grams of water vapor per kg dryer. I can say 0.0163 kg of water vapor per kg dryer. What you are just rounding it off. Okay, kg dryer. Okay, so this is what we have done. And one more thing, specific volume. These green lines parallelly we can determine the point, right? So what is the value here? So this is 0.85, this is 0.87 green lines. So half of it will be 0.86 and this is again half of that. So 0.865. You can say specific volume 0.865 metric cube per kg. Okay, kg of dryer. So this way we can make use of this psychrometric chart. Okay,
take down this problem. So if you look at, assume that the outside air temperature is 32 degrees Celsius with a relative humidity of 60%. So these two parameters, dry bulb temperature and RH, relative humidity, is known. Use the psychrometric chart to determine the specific humidity omega, that is absolute humidity. Okay, so we have to find absolute humidity, we have to find the enthalpy H, we have to find the wet bulb temperature, we have to use the wet bulb temperature TWV and the dew point temperature TDP and the specific volume of the dry air V. Indicate all the values determined on the chart. We have to show the values on the chart. Okay, so that's important. So I have given the answers. Let us see how to get these answers. Okay, so this is the psychrometric chart which we are going to use in our course. So we have dry bulb temperature. I am using this colored chart. Even in black and white, we should be able to see the definitions, means the terms, and you have to get the data. Okay, so we have dry bulb temperature in degrees Celsius. This chart is only applicable for 0 to 50. Extension is not given. So if you have a numerical involving 75 degrees Celsius, we have to make use of another chart. So remember, we have to use a psychrometric chart at atmospheric conditions. Okay, so we have clearly mentioned it is a simplified psychrometric chart at 1 atmospheric total pressure. So on atmospheric condition operations, we can make use of this chart. So we have specific humidity, Okay, so what to do? First we have conditions are given, right? What are the two conditions given? So in this problem, 32 degrees Celsius is the dry bulb temperature and 60% is the relative humidity. So 32 degrees Celsius, here dry bulb temperature 32 degree, humidity is 60 percentage given, 60%. So in this 60% line and 32 degrees Celsius, here we have to mark our point. Okay. So let us say this is 35. So my middle will be between 30 and 35. 32 will be 32.5 is the middle line. So we have point around here. Okay. So this is a 32 degrees Celsius line, and we have 60% our relative humidity line is here. So there we have a point. So that point we have to mark all the points. Okay. So if you draw a line horizontal to this x-axis, what we get is specific or absolute enthalpy. This point we are getting, this is 15, this is 20, so half of it is going to be 17.5. So you are going to have a value more than 17.5, let me say 18 or 18.5. Okay, so that is the unit is given, grams of moisture per kilograms of dry air. So accordingly we have to write. So if I write in kilogram, it is 0.015, 0.02. Okay, so accordingly we are going to get the value here. So what we have to do, using the scale, you have to draw a line parallel to x-axis, and in between 15 and 20 we have to get the value for absolute enthalpy. Okay, sorry, it's not absolute enthalpy, it is absolute humidity. So what we get here is absolute humidity. Okay, so this is the enthalpy line, so we have to get enthalpy line parallel to this one. Okay, so that will give us the enthalpy. Okay, then how to get a dew point temperature? If you draw a line parallel to x-axis and where it gets saturated, that is like you draw a line up to here in the 100% saturation line. So you get the corresponding x-axis value. You will get dew point temperature. Okay, and if you draw a line, this is your specific volume line in meter cube per kg. It is 0.9. It is 0.87. So if you draw a line parallel to these green lines, we will get specific volume. So what is the value? We have to choose. It is 0.87, it is 0.9. Half of it is going to be 0.885. So it is, you have to take a value accordingly. Okay, you can, what you can do is you can use the scale, make equal 5 divisions. You can take the value accordingly. This is how we regularly will do with graph sheets. Okay. Similarly, next point what we can get is, so if you draw a line parallel to this, we are going to get wet bulb temperature as 25, above 25 degrees Celsius, right? So we can get the wet bulb temperature. And if we have seen that the lines parallel, enthalpy line, wet bulb temperature are the lines parallel to each other. So here it is given enthalpy lines 30, 40, 50, 60, 70, 80. So if you draw a line parallel and extend up to here, we will get wet bulb temperature. That red line, it gives us wet bulb temperature. And if you are extending it up to this enthalpy line, we will be getting, it is more than 70 and less than 80. Half of it is going to be 75. It is something more than 75. So accordingly, you can get the enthalpy value using this scale. Okay. So we have a point 32, that's what we're drawing here. So we have a line 32 and we have 60% humidity line. So when you go towards x-axis, you are going to get the value for this one. And if you are going to what's parallel to this wet bulb temperature, you will get a wet bulb temperature. And if you are drawing a line horizontally here, you are going to get dew point temperature, and here we will get the dew point temperature. So if you go further here, extend it, we will get H line, where we are going to get the value for H. Okay. So in this way, you can check values. So you can get plus or minus values, but what I have observed is the specific humidity is, the enthalpy H is 78, wet bulb temperature is just above 25, so it is 25.5, and dew point temperature is around 23 degrees Celsius, and specific volume of the dry air is 0.89 meter cube per kg. Okay, so how I have done, I just explain again. So this is the chart I have taken. So I have drawn a 32 degree DBT line, and it is 60% it is given. So 60% RH line. So there I mark a point. and draw a line parallel to x-axis to get specific absolute humidity. It is specific absolute humidity. Okay, and if I draw a line to horizontal and towards left at the 100% saturation line, corresponding x-axis value gives me the dew point. Okay, so if I draw a line parallel this black line, to these black lines, I will get enthalpy. If I draw a line parallel to specific volume, I will get the specific volume data in the x-axis. And if I draw a line parallel to black lines, I will get enthalpy H value, small h value. What we get here is capital H value. Okay, so we'll get enthalpy data. So those are the data asked, and we are getting the answer in this one. Okay, second problem. Assume that the outside air temperature is 8 degrees Celsius. If the air in a room is 25 degrees Celsius with a relative humidity of 40%, use the psychrometric chart to determine if the window of that room which are in contact with the outside will become foggy or not. When it will get foggy, if dew come on the window, we are going to have window. So that is the hint here. The air is in contact with the windows will become colder until the dew point is reached. So if dew point is reached, so we are going to have foggy. So we have to see what is the dew point temperature. That is the question here. Okay. So if you see what is the dew point temperature, and outside it is 8 degrees Celsius, whether fog will be formed or not. That is the question. Okay. So two data is required to use the psychrometric chart. We have 25 degrees Celsius and relative humidity is 40%. So go for this chart. In this, whatever data is given, that is 25 degrees Celsius and 40% relative humidity is there. So mark those points. So if I mark it and if I draw a line, so this is the point we have to mark, right, for the given temperature and pressure. So if you draw a line parallel to 100% saturation line and get the line at the x-axis, we are going to get dew point temperature. We can see that it is just about 10 degrees Celsius. We are going to get dew point temperature, which is, so even when the temperature is about 10, we are going to have dew point. So if temperature is further reduced, obviously condensation, that is dew will be there. So we can say that it is the value what we get is slightly higher than 10 degrees Celsius. So it is given that outside temperature is 8 degrees Celsius. So what will happen? There be dew. So at that point, the water vapor condenses as the temperature approaches 8 degrees Celsius along the saturation line, and the windows will become foggy. So that is the answer. So this is a simple question. Okay, but first if you know the dew point temperature, outside temperature, so it is less than the dew point temperature, obviously there will be fog. That is the answer for this question. Okay.
So in this lecture, we have solved few numericals on how to make use of psychrometric chart, and if any two parameters are given, how to determine the rest of the parameters using the psychrometric charts. Also we did numericals using the formulas how to determine the parameters for this air water system, particularly air and water vapor system. Okay, so this air water vapor system is used in various humidification operations, including air conditioning systems and in cooling towers. Okay, so in the next lecture we will discuss in detail about cooling towers, its classification of cooling towers, design of cooling towers, what are its components that are present in it. Okay, and we will see some demonstration videos for cooling towers in the next lecture. Thank you so much for joining my classroom. Meet you in next lecture. Bye bye.